So you guys saw what is eddy current, right? Now we'll see a few advantages, disadvantages, or you can just call applications of eddy current. Alright? Okay, see, the first one is we call, there is some galvanometer called as deadbeat galvanometer. Alright? Now deadbeat galvanometer works on the principle of eddy currents. So what you have is you have a very small metallic strip inside the galvanometer and you have permanent magnets, correct? So what happens as that particular metallic piece starts rotating inside that magnetic field linking with the conductor changes. So because of the change in magnetic field, eddy current will be produced. So what happens here is as the galvanometer scale, so the pointer will start moving, correct? Now it should come to a certain extent and it should stop exactly. Now usually what happens in a galvanometer, it stops and then it starts moving like this, okay, because the particular coil inside the magnet that keeps on moving, it keeps on dangling. To stop that, so what we do is, so we keep that small metallic rod inside it, okay, usually aluminum, we use aluminum. Now because of the aluminum, eddy current will be produced in the aluminum and then it immediately stops. So what happens, the dangling of the pointer will be stopped. Alright, so this is basically a deadbeat galvanometer. Alright, so one more application is induction furnace. Alright, see, in induction furnace, so you guys saw the video, that particular clip of video in the previous video, correct? Right. So in that, what was happening, the metallic piece was rotating and melting, correct? That's basically the job of a furnace. So what they do is, they keep giving metal pieces inside, they put metal pieces inside a big copper coil, alright, and then they pass frequency inside the particular copper coil, and then because of eddy currents, metals will start melting. Okay, so this is second application. Third application is we have induction motors. See, induction motor is basically, so usually we use this in fans. Okay, so what you have is, so you have single phase current. So single phase current that creates the magnetic field, and you have a rotor in between those two magnetic fields. So the rotor starts rotating. Alright, so immediately it starts rotating because of the eddy currents produced inside the rotor. Okay, so this is what we call as an induction motor. Alright, now fourth application is diathermy. See, diathermy is used in medicine. Okay, so for heat treatment, for maybe like a backache or maybe somewhere, anywhere, so this diathermy is used. So what we have is, so we have a small copper coil, okay, and then so frequency is passed through it, it produces current. Okay, so it produces current because of the resistance which is there in the conductor, it heats up. That we can use to heal some of the body parts. Okay, so this is one of the uses. Then one more use is we have something called as energy meter. See, in energy meter, so what we have is you have permanent magnets, okay, and then so there is a metal piece which will be moving inside that particular magnet. Okay, so as the metal is moving, eddy currents will be produced, right? So because of resistance, what happens, it will stop moving as in it slows down, you can say. Okay, so eddy currents hinders the movement of the particular metallic piece. So you have to give energy to it, right, to move the particular metallic piece. So how much of energy are you giving, that depends on how much of eddy currents is produced, correct? So that particular meter measures eddy currents and give it as an output. Okay, so if more eddy currents is produced, more energy you have to give to move the metallic piece, correct? So these are what we call as energy meters. Alright, now one more example, this will be the last one, application is electric brakes. So all of you guys have been to metro, right? All of you have been to metro. So metro or any other electric braking happens in a very simple way. See, there is a drum, okay, so there is a metallic drum is connected to the wheels of the train. Okay, so as let's say the train approaches the station, what they do is they give huge metallic field to that particular drum. So as the drum is also rotating with the wheel, and because of huge magnetic field, so what happens here is the change in magnetic field, so eddy currents is produced, so that creates a lot of resistance. Okay, so because of lot of resistance, that stops moving, the drum stops moving. So since the drum is connected to the wheel also stops. Okay, so this is what we call as electric braking. In all the metros and any other trams or electric trains, this is how it happens. Okay, so these are all the applications of eddy current. Now, since we have application, and remember I mentioned in the previous video that there is disadvantage also. So let's see a few disadvantages. See, eddy currents is what? It's pure heat, correct? So one thing, whenever we have eddy currents, lot of heat is generated. So there is a lot of energy loss. Okay, there is a lot of energy loss because heat. Okay, second disadvantage. So since that eddy currents and resistance, these two are inversely proportional, so we need to keep a very low resistance to get very high current. Now low resistance, obviously the economical cost will increase. Okay, like it has to be pure copper or silver. Economical cost will increase if we want eddy currents. Okay, now the third disadvantage of eddy current is see, in transformers I told you that there is laminated core, correct? Now in transformers, even if we use laminated cores, eddy currents will not be stopped, it can be reduced, that's all. Okay, so what happens, because of lot of heat being generated inside the transformer core, the core might get damaged. Not only the core, even the windings in the transformer might also get damaged. Okay, so because of lot of heat we have in the particular system, so this heat has to be minimized. Okay, so eddy currents has a lot of advantages and it has a disadvantage also. So whatever we do in day-to-day life, this eddy current is very useful. Okay, so in the next video you will see what is induction.